Welcome to Module 9 in PCC 288M. You made it. We made it. And we're on Chapter 9, Implementing Advanced Network Solutions. Now we're getting into some advanced types of things that we'll be covering when it comes to networking. Implementing high-performance network solutions and determine scenarios and requirements. All right, so some of these things are going to be very high-end types of discussions that you may not be using or doing as a junior IT administrator. These are things that are going to be covered by definitely more advanced IT people, but it'd be great for you to be exposed to this technology so you can talk about it, and if it's something you want to learn how to do more in depth, then once this conversation is over for what I'm doing, then you can certainly look up a lot of different things where you can see demonstrations, such as your freelynda.com account, which was going to be called LinkedIn Learning here shortly. And you can go and see demonstrations of some of these advanced things, and then try them out in your own lab, and then it'll make yourself, of course, highly employable. So NIC teaming is our first one. NIC teaming allows multiple network interfaces to work in tandem. So this is really nice because if one network card is not enough to handle all the traffic, you can team multiple ones together. Then we're talking about load balancing and failover, and we'll actually, let's talk a little bit about that for a second. So load balancing distributes traffic across two or more interfaces. Failover allows for one server to fail over to the other so the clients are still serviced. I talked a little bit about failover when it comes to file sharing using DFS in the previous module, but this is a little bit different. So NIC teaming used with Server Manager or PowerShell, and this is where you configure, as you can see here in this setup, you configure more than one network card to be able to manage traffic that may be too much for a single network card. Switch independent uses to connect the NICs in a team to separate switches for fault tolerance, whereas static teaming is used primarily for load balancing. So they're used for two totally different things. And the link aggregation control protocol allows the switch to automatically identify ports a team member is connected to. So a little bit more automated. All right, so here's where we create a new team. And let's say we've got two 10 gigabit connections, and here's the teaming mode and the load balancing mode. So you can choose the teaming mode, which we just talked about, the switch independent, the static teaming, or the LACP. Then you've got the load balancing mode. You've got address hash as the default here. Standby adapter, none, or are all the adapters active, or you're going to have an active and a standby. So you've got multiple different options there. Much easier to see it than to talk about it. So the load balancing mode determines how the server load balances outgoing data packets. So you've got the hash, the Hyper-V port, and the dynamic. So in the hash's case, it uses an algorithm based on the outgoing packet's properties to create a hash value. This is something you don't necessarily need to know. This is a little deeper than probably what you need to know. But in Hyper-V port is used when team members are connected to a Hyper-V switch. And this will lead into our software-defined networking conversation coming up shortly. And dynamic is the default mode where traffic is distributed evenly among all team members, including virtual NICs. So the hash is going to be based on outgoing packet properties. The dynamic is going to be evenly distributed between the two or more. So NIC teaming allows these multiple NICs to work in tandem to increase the available bandwidth. Now typically if you have a 10 gigabit network connection in a very large, in a small to medium sized organization, you don't need to do NIC teaming. This is mostly for large organizations where thousands of people are connecting to a server. It may also be used in a medium sized location where you're serving up a lot of video. And the video does tend to use a lot of bandwidth. So if you have, like, say, a web server that serves up a video or some other type of video server, then you would probably want to do this. So this NIC teaming can happen on a physical server, and it can also happen on a virtual server. So you can team up these network cards virtually as well using Hyper-V. So this is what it looks like in the Hyper-V settings properties. And you can check the box that says enable this network adapter to be part of a team in the guest operating system. Data center bridging provides additional features for use in enterprise data centers. It's designed to prevent delays in delivery of data in iSCSI applications. And we want to have what's called a lossless environment. So you probably heard of lossless when it comes to music. Well, there's also lossless when it comes to iSCSI. Well, what's iSCSI? Well, iSCSI is where you connect storage to a server. So let's say that our server has a C drive and it has 5 terabytes. And those 5 terabytes are being mostly used up. Well, that server has no more space to add any more hard drives. So how do I get more data on here? How do I get more storage available? Well, I can do that through iSCSI. So I'll connect another server using the iSCSI target service installed, or I can buy a SAN specifically designed for iSCSI. Either way, and then I can connect through an Ethernet connection between the two and set up what's called iSCSI. Well, the problem with iSCSI is it uses a lot of bandwidth. So you may need to use what's called data center bridging in order to have no loss between the data and the server itself. So data center bridging improves iSCSI connectivity by adding quality of service. So you can decide which traffic is most important. So you have lossless data transfer, deterministic performance, and DCB exchange. So it supports DCB as an installable feature using the Add Roles and Features wizard. If you want to manage the DCB configuration, then you've got to do this through a PowerShell command, as you see here. So if you want to configure quality of service, we have used quality of service in making sure, say, in an IP phone situation where it shares data with the phone. You may want to say, okay, I want the phone connections to make sure they have the highest quality, the most amount of bandwidth. And so quality of service is very popular, being used in a firewall for that reason. Well, quality of service with data transfer can be used in a similar fashion. So you can say certain data is more important than other data. So maybe video data is not as important as, say, accounting data. And so the accounting data gets a higher quality rating than the video data does. So QoS policies can be used set up using the PowerShell commandlet that you see there. And you can prioritize SMB traffic, for instance, and it shows how to do that here. You can also create what's called traffic classes, so you can give weight values to certain types of traffic, like I mentioned earlier. And there's the PowerShell command to do that as well. Virtual machine queuing. This accelerates the virtual network interface card by delivering packets from the external network directly to the VNIC. Now, this is a new feature that basically was created because a lot of the virtual machines were getting choked out when it came to bandwidth. So the network interface card manufacturers helped create this special priority so the traffic can get to the virtual machine more quickly and more efficiently. So you can create this queue to have that happen. Receive side scaling, a feature for network drivers that efficiently distribute processing of incoming network traffic among multiple CPU cores. So this is something else that it was basically a need for network cards to be able to use all of the CPU cores, and sometimes some cores are overloaded and some are underloaded. So you can use receive side scaling to actually balance that load between the different processors. And that is turned on by default. So here's an Intel card. Again, this was all designed by the card manufacturers themselves, and it's supported in Windows. By default, you can see receive side scaling is enabled. And there's also a virtual receive side scaling. So the one I was just talking about was for physical network cards. You can do the same thing for virtual network cards as well. And if you want to just see the status of it, you can type the get-net adapter VMQ. Virtual machine multi-queue, a new feature to Windows Server 2016. So in 2012, it did not have this option. Reduces the overhead of getting packets from the physical to the virtual network. So even though we've got receive side scaling, we've got virtual machine queue, it's still not enough. The virtual machines are still not getting the traffic in a timely manner. So they came up with another feature. VMM queue. A VM can be assigned multiple queues on the host adapter with each, so the other one, remember, just set up the queues. Now we've got multiple queues, with each queue having a virtual CPU core to process its incoming data. So when you set up a virtual NIC, it's not just using the network interface card itself, it's using what's called a virtual processor. So now we're actually using processing power from the server's CPU, not just the NIC itself. So you can enable all of these queues so the traffic comes in as quickly and as efficiently without any packet loss as possible. And you can set that up using PowerShell. SRIOV, DFS fault tolerance, ensures continuous access to users' files. So if we're using DFS, then you can load balance that information using SRIOV. SMB Direct and SMB Multichannel. And all of these different features, whether they're new to 2016 or 2012 or 2008, it's all about getting the data without losing it and in the most efficient and quick manner. So another one of these is SMB Direct and SMB Multichannel. So a performance technology designed for the SMB protocol. Uses capabilities of an RDMA capable network adapter, which directly sends traffic to the operating system without having to go through another device. So it's a direct memory access. Requires the host network adapter to be RDMA compatible. So if the NIC itself is not RDMA compatible, then you can't turn these features on. So all of these different features require the network card and the network card drivers to support them. Otherwise, you cannot turn them on. Multichannel provides fault tolerance, improved performance, and a connection between a client and a server on an SMB share. One of the problems with SMB, server message block, is it uses a very large data packet. It typically uses almost 1,500 byte packet. And that's very large. And so sometimes you have to break those into smaller pieces to send them through very slow connections. So you need to make this more fault tolerant. You need to make it faster. A lot of times, sometimes those packets, when they get reassembled, they get done in the wrong order, which causes them to have to be resent, and you get a slowdown. So every once in a while, when you see your hourglass show up and it's spinning around, it may be because you had a breakdown in your SMB channel where these packets had to be reassembled. And this protocol helps resolve that. Software-defined networking. This allows administrators to centrally manage aspects of key physical and virtual infrastructure devices such as routers, switches, and gateways. All right, so here's the problem. Virtual machines require a lot of hardware. Unfortunately, you're not going to have enough places to put all this hardware. So Microsoft said, hey, you know what we're going to do is we're going to make all this hardware virtual. And it really ticked off Cisco, let me tell you that. So now you no longer need Cisco and some of these other Juniper and some of these other manufacturers. You can do all of your routing and all of your switching for virtual machines virtually. You no longer need hardware to do routing and switching when it comes to virtual machines. And software-defined networking allows you to do that. So Microsoft said, hey, you can create a virtual switch, a virtual router, a virtual firewall, all these different things you can make virtually using software-defined networking. But you've got a lot of requirements in order to make SDN work because it's a fairly complex type of a setup, and many people will never learn how to do this. So Windows Server 2016 Data Center with Hyper-V, and at least one RDMA compatible 1 gigabit network interface, although I'd recommend 10 gigabits and 2 or more. DCB compatible switches, which you talked about, data center bridging, administrative access to all physical network devices such as routers and switches. So that is the requirements just to get started. Then you got to set up Hyper-V. So with Hyper-V network virtualization, you've got a lot of benefits. It provides isolation. So basically what you can do is you can create subnets behind subnets to protect your virtual machines from any kind of attack. They may get through the hacker may get through the first subnet, but then, oh no, they got a firewall between the first sub and the second one. Then they got another one between the second and the third. And so obviously you can make it too complex, or if you have a problem, it's really difficult to troubleshoot it. But you can also make it a lot more secure by using this technology. Another great thing about using Hyper-V network virtualization is you can use it with Azure for cloud services or other locations. So let's say your server, DC01, is on a 192.168.0.1, and it is a virtual server. and it is using software-defined networking. So what I can do is I can say, hey, this server is not, this physical server that DC01 is running on is not running very efficiently, or it's been compromised, or I need to reboot it for some reason. And I'm going to be bringing DC01 down to do that. So what I can do is I can live migrate DC01 to another Hyper-V server using software-defined networking. I don't have to change the IP address of it. I don't have to bring it down. I can just say move it, and it moves. And then I can do whatever I need to do to the physical server it was hosted on, and I can bring it back again if I want to. So that's what software-defined networking can do for you. Very cool. HNV uses the term routing domain, a virtual network with one or more subnets that are isolated from other virtual networks. As I mentioned earlier, you can have subnets behind subnets. Each routing domain is assigned a routing domain ID. And then each routing domain can contain one or more virtual subnets. All right, so here is what one of these software-defined networking virtual setups looks like. You've got tenant ABC and you've got tenant XYZ. You've got one subnet, 192.168.1 and then .2. And then over here you've got 192.168.0 and .1. And then you're using a distributed router, which is software. It's not a physical router, it's a software router running on the server. So you can, with HNV, you can tunnel networks by associating each virtual network adapter with two IP addresses. One on one subnet, one on the other. So you can see the virtual networks. You can see 192.168.1.1 on one side, and you see the same subnet on the other. That's what's great about software-defined networking. You can have the same subnet running in two completely different physical servers that have different subnets of their own. Couldn't do that before. This is all brand new stuff, very difficult to set up, but once it's set up, it's a great feature to have. Virtual Extensible LAN is a tunneling protocol that operates over UDP. So you've got to have a way for these virtual machines to talk to each other, and they do that using this tunneling protocol. So there's more than one. They can also use what's called GRE, which is an older, less secure technology, or you can use this newer technology, VXLAN, for the virtual machines to communicate with each other. Network controller server role is only available in Windows Server 2016, so if you have previous versions, you can't do it. So this is a new server role in 2016, and you got to use the Data Center Edition, and you've got to use software-defined networking version 2 in order to make that work. Software load balancing. It's a software-defined networking feature. Allows a hosting provider to distribute tenant network traffic across virtual network resources to increase virtual network performance and fault tolerance. So you've got to understand the traffic direction. There's north, south, east, and west when it comes to software-defined networking. So east-west traffic is any network traffic between virtual networks and servers within the data center. So if you have virtual machines in the same physical location, we refer to that as east-west traffic. North-south traffic is a little different. Network traveling between the data center and external clients we call north and south. And we need to understand that because when you set up your software-defined networks, your subnets, you have to define whether it's east-west or north-south, so it knows whether that traffic will not leave the data center or whether it is designed to leave the data center. So to route traffic between virtual networks and the physical network, it requires this Windows Server gateway. So it's got to be this virtual router I was talking about earlier. Layer 3 forwarding, GRE tunneling, site-to-site VPN, and a NAT gateway. So it has all those types of implementations that you can do. The gateway implementations are multi-tenant aware. So this is perfect for a private cloud or like an Azure type of a setup, where you have many different companies all sharing the same physical hardware, but they have their own secure software-defined network virtual machine. So they can't talk to each other because they're different companies. And so you want to keep that separation in a multi-tenant situation. And since software-defined networking is multi-tenant aware, then it is a perfect type of thing for hosting servers for multiple clients. So if one of your goals as an IT administrator is to have your own consulting company, and maybe you want to rent out a data center, maybe a cage in a data center, as I have done, then you want to set up software-defined networking to protect the tenants from each other, but still give access to the tenants from the outside in. Distributed firewall policies is another part of software-defined networking. It's a new feature in Server 2016. It enables network administrators to manage firewall policies for all data center virtual networks. So you can say, hey, this firewall is allowing HTTPS traffic through. This firewall is allowing VPN traffic through. And they all go to different subnets and different servers. Before, you had one firewall, and that one firewall allowed traffic in and out, but it didn't specify different subnets and what you could do with them. Now, with a distributed firewall, you can split that all up. Make it multi-tenant aware if you want, or if it's just a single company, you can make it server specific. So this is a great feature. Distributed Firewall Manager works with the network controller. So you have to have the network controller role installed in software-defined networking. There's a northbound interface that goes to the SDN controller, and a southbound interface where policies are sent to the network device. So this is what it looks like for your firewall policies. You can see the network controller, the northbound interface, southbound interface. This is not the same as the east-west, north-south traffic. This is just what we call the interface itself. And you can see the different virtual machines, and then you can see, hey, I've got 3 different firewalls. They're all software-based, no hardware here, except for the physical host itself. And I can have rules for each of my virtual machines that are all separate for each other. All right, we talked a lot of really advanced stuff here. NIC teaming, different modes for NIC teaming, talked about data center bridging, talked about prioritizing traffic with quality of service, virtual machine queuing, software-defined networking. So lots of really advanced stuff. And these are things that you can pick and choose, excuse me, which thing is the most important to you in your career. If you're thinking about a career in security, then these are things that, many of these things will be things that you learn about. But even if you're not considering a security-specific career, you still have to be security aware. So you need to be aware of what these different things do. So that covers it for 288M. If you haven't already been in 289M, then we've got a great program for you there as well. Thank you for being a part of this class, and good luck to you and your graduation and your future job that it was going to be your great dream job. I hope that that is yours, and I'm always available to talk, not just during the term, but even after graduation. You can always find me and ask my advice about what you're getting into in your career. So thank you again for being part of the course.